the value inequalities that like less than means an and inequality, so it's going to be shaded in the middle. Greater than means an or, so it's going to be shaded on the outside. That works great when it's just and or. It's more complicated when you have more places to check. And so that's why you have to know how to do that sign chart and check to see where would I shade in this problem. So really easy. They're all set up perfect for you on these problems. Could you tell me the zeros of this equation? If I said solve that, if it was equal to 0, what would you say? -1 and 3. Kind of going back to what we did in chapter 2, part 1. If I asked you to graph that, you'd be able to tell me that at -1 it's going to cross because it has a power of 1 up there. Notice that at 3 it has a multiplicity. So at 3 it's just coming down. We could talk about in behavior, right? We've graphed those already. That's why I'm not going to make you graph them again. But what we have to do is figure out if it's greater than that, where would we shade? And that's where, if you don't have a graph to look at every time, that's where you can make that little chart, right? -1 to 3, and you just check the numbers in between. You remember doing this? Yes. Really nice when there's only 2 numbers. It's a little more complicated when there's like 4 numbers to check. So this is where you just check to see does it work. And so you just pick a number less than -1, whatever number you want. I usually just go 1 less than -1. So like I would pick -2. And I always just look at this and say, would it work, right? And you have a calculator or you can just work it out. I always try to do it without working it all the way out. Like if this is squared, no matter what I plug into this one, it's always going to be positive. So all I'm really looking at is what happens when I plug -2 in here. -2 plus 1 is a negative. So that means that does not work, right? That's a negative answer. I want it to be greater than 0. So that's not right, right? Or what did we write there before? We wrote no. Do you want to just type in your calculator? Type in your calculator. With the fractions, I like to work them out. -1 to 3, I'm always going to pick 0 in the interval where 0 is. So like for this one, I'm going to pick 0. And again, I'm really just looking at this one because this one's always going to be positive. So 0 plus 1 is positive times a positive. It's going to be greater than 0. So that means yes. And then greater than 3, what about greater than 3? Is that going to work? If I plug 4 in there? Yes? Positive, positive, yes. So notice that this graph kind of helps us see what's happening there. We're shading everything between here, right? Between -1 to 3 and everything on this side. So what happened here is we shaded everything below the curve is actually what happened on that problem. That would have been hard to tell without graphing it, but that's what we just figured out. All you have to do is write your answer in interval notation again, right? I like to just do the x-axis of where I shaded. I want everything from -1 to 3 and 3 to 4. Could I say this? Oh, I said 4. Could I say that as my answer? Everything from -1 to infinity. No is the answer. I want you to tell me why. Why is that not right? A circle thing? Yes, a parenthesis. That's part of the problem. Yes, because why is -1 a parenthesis and not a bracket? Is there not some parentheses? How do you know whether to use brackets or parentheses on inequalities? This tells me whether it's bracket or parenthesis. Yes? So what else do I have to do to fix this? Because is every number from -1 to infinity included on this problem? What other number do I have to skip over? Because actually included, right? Like this would be a dotted line. So because it's only greater than, although everything past 3 works, 3 is not actually included. So you would want to say -1 to 3, skip over 3, and then from 3 to infinity. I was talking about 4 over there, and that's a really easy thing to happen is when you write your number that you're checking, sometimes it's easy to want to write that number down. So I try to write them smaller or write them above it or write it somewhere different so I don't get confused with those because I almost wrote it down earlier. That would be my answer. You're, right here. That's all you got to know. If it's greater than or less than, it's a parenthesis because it's not included. If it's greater than or equal to or less than or equal to, it is included. And so that's a bracket. Alright, so that's polynomials, and the polynomials today, they're not going to make you do PRZs. They're going to all be factored for you. You just got to find your zeros and check where they were. But they're also going to give you rational problems, which means x's in the bottom. And there's an extra step when there's x's in the bottom because you have to think about where those asymptotes are without having to graph it. So I'm going to double page this so that we can go through the steps as we do the problem. And my advice is, if you like to write the steps down, write down the steps as we do it. And so that way you don't get bogged down with writing all this at once, if you want to write it down. So, can you see that? All right. So I'm gonna like do a step at a time as I go through there. The majority of your homework is gonna look like these. Let's see if I can make this a little bigger. So like 72. Whoa, that's unfortunate. Okay, well, let's just stop before I delete everything. Okay, so here's the extra step. When you solve a rational equation, you have to consider where it's undefined. Where are the asymptotes? And that's my step 1. So step 1 for me, so I don't forget, is I say, what can't x be? Because if it can't be that number, I'm going to have to skip over it when I write my interval, just like we had to skip over 3. So for me, on this one, step 1, set the bottom, can't equal 0, right? Just like you were going to say the domain of this, or you're going to find the asymptotes of this. Find any value that makes the function undefined. So then I'm going to do that over here. So that's really, hopefully not that bad to solve. X squared can't equal -4. So x can't equal, goodness gracious, I can't do my math, plus or minus 2. Right? So I would have 2 vertical asymptotes if I graph this at 2 and at -2. That means when I make my number chart, my sign chart, I have to include those points I have to skip over. Step 2, solve the equation just like we solved yesterday. Forget about the inequality sign for a minute and just solve that equation. Super great is when it's equal to 0 or greater than 0. So this is my step 1. If I multiplied both sides by the denominator here, so if I multiplied this side by x squared minus 4 and this side by x squared minus 4, since this is equal to 0, do you agree we just get the top equal 0? I love those problems. So I'm just going to say x minus 1 equals 0. Because 0 times all that is just 0. So I get x equals 1. What does that mean? It means if I graphed that, the 0, the x-intercept would be at 1. I would have asymptotes at plus or minus 2. Step 3 is figure out what numbers are going to go on your number line to check. And the numbers that go on there are your answers from step 1 and step 2. You have to skip over the values that are undefined plus you have to take into consideration your zeros. So I'm going to come over here for step 3. So I wrote use answers from steps 1 and 2 to set up intervals. So I've done this both ways. Sometimes I write the intervals right away. What I've been doing lately is doing that number line like your book does. And so I just put them on there in order. So I say -2, and then 1, and then 2. Right, and I'm just going to check in between there. If you want to go ahead and set up your intervals and say -infinity to -2, -2 to 1, 1 to 2, and set it up like that, you could do that as well. And then step 4 is what we just did. Check each interval and figure out where would it be true. Where would you shade on that graph? And that's where I'm going to go back to this original problem. All right, go back and look at that inequality sign. And so it's kind of up to you on how much work you want to show here. But if I picked -3 there, again, you could actually work it out. Since it's just greater than or equal to 0, I just look to see whether it works out to be a positive or negative on the top. So if I picked -3 minus 1, I know the top of that's going to be a negative. And then 9 minus 4, right? -3 squared minus 4 is going to be a positive. And a negative over a positive is not greater than or equal to 0. So I don't even like stress about the numbers if I don't have to, but I know I'm not going to shade there. Right? Just like we did before. And this is the part that just takes time, right? On the test, I'm probably going to give you 2 of these questions because it takes time to do. You have to just go through and check them. There's not really a shortcut here. On this one, I'm going to pick 0. And if I pick 0, I can see that would just be 0. And I would be left with -1 over -4, which is positive. So that is greater than or equal to 0. So I know that I would shade there. Or you could shade the line there, however you want to do it. Between 1 and 2, you're going to have to pick a fraction or decimal. Use a calculator to help you. Again, I just kind of use it to figure out the signs there. If I picked like 1.5, 1.5 minus 1 is positive. But 1.5 squared, or that's 3/2 squared, would be like 9/4. So that's 2 and something minus 4. That's going to be a negative on the bottom. So I can figure out that that's not going to work without actually having to type it all in. If you're typing this in your calculator, my advice is do the top and the bottom, or if you're typing it in all at once, you have to make sure that you put parentheses around the numerator and the denominator. And then if I pick a number bigger than 2, I think that's going to work, right? Because I'm going to get a positive over a positive. And then the really, really important part, right? This is the work to show, but then the answer is going back and writing them with the interval notation. And this is where you got to be really careful, all right? This is where you got to pay attention to your brackets and parentheses really, really closely. Because this sign tells me that I should be using what? Brackets or parentheses? Brackets. But that's only true for step 2 answers, right? Look at step 1. Am I ever going to use brackets on asymptotes? No, which means on these problems, you could have some brackets and some parentheses in the same problem. So this is always going to be parentheses, right? No matter what the sign is up there, because these are not values on your graph. They're not in the domain, so they can't be brackets. But this sign determines whether you use brackets or parentheses on your zeros, right? So determined by inequality in problem, which in this case is a bracket. And that's a really easy thing to miss, and my hope is tonight when you do the homework that you'll check your answers in the back of the book, and if you use all parentheses or all brackets and then you look back there and you see the mixture, it'll remind you to go back and check. Like, oh yeah, I forgot to do that. So on this one, 1 gets a bracket, but everything else gets a parenthesis. So we could say parenthesis -2 to 1, but 1 is included. And then jump to 2. 2 is also an asymptote, so that's going to be parenthesis 2 to infinity. takes some time to do, especially if you're checking on fractions. All right, we should try that. I'm going to go back to one. It's going to be gigantic. Oh, that's not what I wanted to do. Single page. There we go. Let's try this. Step one's the easiest step to do, but it's what people forget on the test. Like you just automatically go into solving it and you forget to exclude the values, right? So that's why I say do it first before you get into solving the problem, because it's easy to just solve it and forget, hey, I have to exclude what makes my denominator equal 0. So if I asked you for the asymptotes on this, very quickly you would tell me that x is not allowed to equal -1 and x is not allowed to equal 3. And that's why I put the line through the equal sign to remind myself to put parentheses around those in my answer. And then to solve this, like that's what we did yesterday, right? That's where we find the common denominator. We're going to multiply everything by that common denominator. Again, really nice that it's equal to 0. So hopefully you feel pretty good about that I'm going to multiply this by x plus 1 and x minus 3. And kind of just ignore the inequality sign. Solve that equation. Plus x plus 1 equals 0. Do you agree with that? So that doesn't even work out to be a quadratic like we did yesterday. So I get 2x minus 2 equals 0. X equals 1. So now is just the part that takes the time to do, right? Now we have to just make that chart. I'm going to rewrite my problem up here since I wrote all over that one. This one I have to show a little more work on because it's two things added together. So either we could get a common denominator here, so we could look at whether it's less than or equal to 0, or you can just look at each fraction and see when you add them up, is it negative or positive. So this one you really do have to just kind of spend some time doing it. If I picked -2, so I'm just going to write down here, -2, I would get what? -2 plus 1 is -1, so I get -1 plus 1 over -5. So if I get a negative number plus a negative number, like that's going to be negative, so that's going to be less than or equal to 0. So I can say for sure that works. What happens a lot is somehow people mess up the math here, and they got the right numbers, but when they check it, they're not getting them correct. So you just want to make sure that you're typing that in your calculator correctly, or you're paying attention, because I'm easy to mess it up as well. 0, I always pick 0 if I can. So like down here, I'm going to put 0, and I'm going to do my work here. So if I put 0 in here, I'm left with 1 over 1. Plus, if I put 0 in there, I get -1/3. 1 is bigger than -1/3, so that's going to be a positive answer, right? So that one's not going to work. Some people like to guess on these, like they feel like if they get yes and then no, they automatically know it's going to be a pattern. It doesn't always work. Sometimes you get 2 no's in a row or 2 yeses in a row. Sometimes you could get no on everything, which means there's no solution, like it never would be shaded there. Sometimes you can get all real solutions, which means everything works. Well, except for asymptotes, but just know that there are exceptions to the rule. So I always say check it. I check it still. So on this one, I'm going to pick 2, and that's going to be 1/3. And then now 2 minus 3 is going to be a -1, right? So I think the next one works, because 1/3 minus 1 is going to be negative. So I say yes there. And if I picked 4, I can already see that one's not going to work because I'm going to get 2 positive numbers, right? I'm going to get 1/5 and 1. Both are positive, so that's not going to work. All right? I don't need to see all your work for that, but if you want me to give you partial credit, if you get it wrong, I need to see something that you were checking numbers in a little bit, right? So like this is my work. It kind of is a mess, but it sort of is organized as I go there. And then don't forget to take that and write it in the math notation, write it in the interval notation. Remembering which ones we're not including, right? -1 was an asymptote, and 3 was an asymptote. So I think my answer here would be -infinity to -1, not included. 1 is my real answer, and it is a bracket based on that. So bracket 1 to 3. Right? And the back of the book uses interval notation too, so you'll be able to check those. Questions about that? As long as you can remember to include your asymptotes, it'll work out pretty well. What happens is people only check 1, right? They forget this part, and they only check 1, and then they miss a lot of points because they didn't check all of them. I think I have another one, but oh look, I did it. Do not graph, right? If you want to graph, you can, but you don't have to graph. A lot of these say support graphically or solve graphically, but they mean with the graphic calculator, and since we all don't have them, we're just going to focus on the algebraic solving them. So 13 and 14 are the polynomial ones, which means you can either factor them very easily or they're already going to be factored for you. 45, 46, and 50 are like the ones we just did. And then I have a couple, 58 is like a story problem, and then I'm guessing, oh yeah, 67 and 68 is multiple choice. So not that bad there. This will be our last book assignment besides the review that we have for the test. And so tomorrow we'll go through this, and we'll talk about the review, and then Thursday the review will be due so that we can talk about it and make sure we can answer all the questions that we have before we take our test on Friday. Okay? Look at us, 5 minutes to spare on the Friday day. I think you're not getting report cards in Pride Time today. This is a failure, epic failure of the report card part. I don't know when